Good afternoon, everyone, and welcome to Workshop 5, Getting Started with Midnight and compact part of the Cardano Hackathon Asia IBW Edition 2025, with Hack to Skill as an innovation partner. I'm Nidhi, and I will be your host for the session today. In today's workshop, we will explore the Midnight blockchain and Compact, a privacy-focused developer-friendly smart contract language utilizing zero-knowledge privacy-focused developer uh, zero knowledge proofs. You will learn about Midnight's unique privacy features through practical use cases like DEFI and private voting and gain experience writing, testing, and deploying compact contracts. Excitingly, the total price pool for this track for this hackathon is 65,000 USD stablecoin across multiple categories, including first prize, second prize, third prize, plus bonus awards for best meme integration, privacy in action, best UI UX, and best Hydra implementation. This is a crucial time. Our hackathon is moving forward to its last stages. Ongoing mentoring and workshops will support you leading up to the grand finale in Bangalore on November 29th and 30th. Today's expert presenter is Idris from the Midnight Foundation. Idris would lead us through the workshop, sharing insights, demos, and answering your questions live. Over to you, Idris.
All right. Hi, everyone. Sorry, just to confirm quickly, am I audible?
Yes, you are.
All right, perfect. Thank you so much for that intro, and I'm really excited to be here. So I'm just going to share my screen real quick. All right, I think my screen should be up right now. Um, yes, good. Hi, everyone. Once again, wherever you're joining from, my name is Idris Olubisi, and in today's session, we'll be talking about getting started with Midnight and also Compact. We'll take a deep dive into what are some of the things you should know when building on Midnight, and also how can you get started building, which is the most important part of this talk. So, my name is Idris Olubisi. I'm on the DevRel team at Midnight. I'm a developer educator, and you can find me on all social at Olanesoft. So, like I mentioned earlier on, in this session, we'll go through a couple of things. And then the first part is we talk about what currently exists in the web today, which is the traditional web application, building your regular web application. Then we talk about Midnight, what Midnight is, why Midnight. And then we go ahead to discuss how does Midnight work for those that are curious to know what is happening under the hood, how is privacy achieved, and all of that. And then we go through several use cases that you might, be familiar with already, and also what are some of the type of application you can build during this hackathon. And then finally we look into like building on midnight, and then we take a look at the resources that we have available. One important thing here is that we're having a quick demo session where we are going to go through an example together. We will go through the testing and also deployment together. So now, in the beginning, we are all familiar with web applications today, and how what are some of the things that you could do with them. If a user send a request today to a particular server, you send a request, and let's say you want to access a website or a particular social application, you have your URL, you send data across this website, and also you could require like login, and that means that you have to sign up, you have to fill a couple of forms for you to get access to the website. At some point, you send in all of this information with the purpose of logging in to the website, but sometimes you are giving too much information to that particular company that's helping you host that website. So it also means that there could be a misuse of sensitive data during this process, and that could be used by anybody that would have access to this data on the site that you supply the information to. But this is how things are today, and this includes what you would experience for any web application. But then, if you look at what Web3, the whole idea of Web3, what it proposed is some level of ownership, building a decentralized application that can allow you to own the entire process, and also allow you to own what it is, what kind of information that you supply, and of course, what kind of information the website that you're supplying those info could have access to. But traditional blockchains are good, but most importantly, they have some flaws. If you look at what I talk about when it comes to decentralized application, where you have ownership, it's similar example, just like you can see on my screen right now. You have a user trying to access the internet. But now, if you take a look at the diagram very well, you would see that there is something included in between the user's request and also the company that is trying to access, like the company website that you're trying to access, and that is the blockchain. If you're familiar with blockchain, I don't want to go too deep into what blockchain is or how it's or what happens under the hood, but to keep things simple, it's a decentralized system. It's a system that allows you to build a decentralized application, and also you have a couple of information on chain during this process. So what does that mean? Building a dApp means you are replacing the whole traditional saving of data into the database or doing all of these things, because by default, blockchain serves as a database for you in this case, where you could have all of this information saved on chain. And on chain then means that only whoever is interacting with the chain at the time would have access to some certain level of information, and also including your information, which also work today. Because we have so many dApps today, you might have tried, Uniswap before, all of these swap platform. They're pretty much an example of dApps that you might have interacted with, and also how blockchain helps under the hood with all of this information. But that's exactly how public chain works today. But one important thing to call out here is that blockchain data are all readable online. And it also means that every information that you get saved on the blockchain is available to anyone. That's the design. It's available to anyone by default, and then you can't control who needs to see what. If I get access to your wallet address, for example, I can see you sent 10,000 USD to somebody recently, or you received a certain type of NFT, or all of the activities that you're doing on chain. I could see it by just going through the details on your address. But how do we, if you look at it, um, public data, it means that all of your interaction are public by default, and there's literally nothing you can do about it because that's how it is designed. But what's the solution here? How can we make sure that if I am connecting my wallet to a particular DApp, I'm not revealing all my information except something that is required for me to access the DApp? An example here is if I want to prove something, or if I want to reveal my age, I don't have to reveal my date of birth. I don't have to reveal, a lot of information that are personal to me, all in the name of revealing how old I am for a particular platform. That's a very rough example, but don't worry, you get to see what that looks like in a moment. So now, what exactly can we use to solve this type of problem, or how is it supposed to be solved? That is where midnight dApps comes in, right? It's also similar to what you've seen before, building decentralized application. But the key difference here is that if you take a look at the design, you see that we have the same flow, but now we have additional things, which includes, private data staying on user device. And then when you are making a request to a particular server, no one is collecting your data. In between that request, what you are doing is you don't share sensitive data. All you need to do is to generate a proof, and the proof goes on chain. And in this case, depending on which options you have, you can see here we have unshielded and also shielded data, right? If you look, the unshielded data means it is visible to all, but not metadata. But then for shielded data, the it also means that um, data are shielded from the public and also the company that is trying to access, um, that you're trying to access. So in this example where I want to log into your site and I want to send you a particular data or prove to you I have something without revealing the actual data, that's how Midnight can help you make sure that you can, what you are sending over, it's only a proof for a particular action without sending an entire data. And you can send all of that through your smart contract when you're trying to access any particular decentralized application. And it also means that no company would be able to save your data along the line when you're trying to do this. The important thing I also wanted to call out here, which is the critical part of how Midnight's digitalized application works, is data and metadata can be shielded, but private data remains with the user. This is exactly what the whole flow you are seeing on your screen right now describes, on how you can build a dApp that is privacy preserving on Midnight. Now, which brings me to the other point of why should I even care in the first place? Why Midnight? So it's important to know that utility should not come at an expense of privacy and ownership. Because I want to have access to a particular information on your website, or I want to have access to your website because you provide a particular service, I shouldn't have to reveal unused or sometimes unintended information to you because I want to access that kind of information. And so that I want to access your website or any application that you're providing as a company or as a project. Another thing to note here is that privacy is human right in this digital era. And if you look at it closely, it plays a major role on how every institutions today are thinking about application. So let me give you an example here. Is you have, imagine JP Morgan, for example, they have their financial record and the financial data. They wouldn't want to share all that kind of information publicly. They would need some level of privacy in a way that they could control things and also manage things internally. But that's just a very rough example, and that's a very good use case, particularly for enterprise or mainstream adoption in the blockchain space included. Now, another point is you tend to like reclaim freedom of association, commerce, and also of course freedom of expressions. So the fourth generation blockchain that is available on the internet today, and a blockchain that can keep a secret, a blockchain that can allow you to choose what you want to keep private and reveal what you want to put publicly, is Midnight. And that is why we need Midnight, and that's why Midnight exists. So now, how does it work? Like, this diagram contains like a very architectural overview of when you send a request, what happens from one stage to another. So it's very simple, but there are just a couple of components that you need to understand here. If you take a look at the Compact compiler, this is referred to as like the dApp developer system. So that's your local system. And that points directly to this session called My Midnight app. But if you look at this, that's not the only component here. We also have the TypeScript code, which is also another interesting thing you get to see later in the demo session, where you see how TypeScript compiles and what are some of the things you can do writing TypeScript code, and also the Compact programming language, how easy it is for you to get hold of it and then utilize it. And because of the familiarity between the Compact programming language and also TypeScript, it makes it easier for anybody that is already familiar with the JavaScript and TypeScript code, or that have already been writing smart contract before. You can quickly get started with Compact. And then if you look at this session, this part, we have the Midnight app, and then we have the Midnight Lace Chrome extension. Midnight Lace Chrome extension is the wallet that you can use to interact with your Midnight app. And then combining these two falls under the browser category, where you have everything going on. And still on the browser category, we have also additional component, which is the proof server that is connected here. So it means that you can generate a proof whenever you need to send an information to a particular website and you've logged in via the browser, you've connected your wallet. You can generate a proof for a particular action depending on what is requested from the site, and then before submitting that particular request. And to submit that request, that goes through another part, which is the Midnight client service, where we have the indexer, the Midnight non-voting nodes. And this is how interaction happens, and this is how Midnight works primarily. Whenever if you zoom out from the dApp developer system to the web browser and then to the Midnight client service. Now, moving on, it's very important to know what are some of the applications that you can build today with Midnight, and what are some of the use cases available to you as a developer to leverage when building with Midnight. One use case is, we have a lot of use cases. In fact, there are lots more use cases than these, but these are just like top level use case, particularly for identity, for finance, for healthcare, and for gaming. For identity, there are a lot of things you could build for an identity solution. In fact, you could also implement DIDs or work with something that would allow you to have a unique identity for humans, and then leverage that on building your application on Midnight, and extend that functionality in such a way that when you are able to build an identity solution, you can also make sure that they have there's a privacy part of it built into what Midnight offers by default, that you can leverage within your app, within your decentralized application. So, of course, for finance also, which is the JP Morgan example I gave earlier on for enterprise solution. And then we also have for healthcare. Healthcare or like health data are quite sensitive and also very important. If you are moving around from let's say you change your environment and you already have a data or a medical record in a particular hospital, and then you are moving around, maybe you're moving to another location. Now there needs to be some level of data that needs to be shared across. How can you make sure that the kind of data you're sharing to the new location is the only data they required and only data that is needed during this process? And how can you also make sure that you can share all of this data in a way that you don't review the actual data itself? So it's very important to know that during this process, there are a couple of things like I showed earlier, like I mentioned in the previous slide, on how Midnight works, on how you can review this information without actually reviewing all of the data under the hood. And then finally, we have the gaming part. And this gaming ecosystem, it's a very big ecosystem. And then there are a lot of things that happen, visibly, but there are also use cases where you could have, gameplay or a strategic move that you don't want it to get revealed before you make those moves. And this is where Midnight steps in, to help you achieve that. Now, building on Midnight, what do you need to build on Midnight? What do you need to get started building on Midnight? We've discussed a lot of things around use case, around viability, and also what you need. So you need compact programming language. I mentioned this briefly, but just to touch on it, compact programming language gives you a couple of things out of the box, right? And I pointed out a few of them. When writing compact, generally for smart contracts, public and private state interoperability is what you get out of the box leveraging this. What does this even mean? User should be able to express, private and public computation easily across different implementation, and also ensure that the integrity of that particular data is reviewed via ZK circuits. Yeah, what does this mean is that within your contract, you should be able to have a language that can allow users to express their private and public computation. That means I should be able to design or write a code that can allow user to share the type of data they want to share, allow user to have this flexibility across the type of data they can share while interacting with the contract. And this is one of the things you get with compact language. Another one is safety is also very important, because by default, privacy is hard. It's very hard to achieve. That is why a lot of process, a lot of design is being put in place on Midnight to give you what it is today. So, and how can you have a programming language that can allow you to integrate easily into that kind of infrastructure? So Compact should include tooling that can help users reason about it, right? Because you want to have a programming language that you are using to build this private, solution, and make sure that it's safe for any user to use. And then my most interesting part of the whole compact programming language, which I also believe that everybody listening right now would find it, very relevant, is familiarity. It means that it's a critical part, because we know what it takes, and also like the friction to get you to learn a new language, to get started, and all of that. But one of the core principles here is that developer should feel like the language is familiar, which is, if you look at it very well, JavaScript and TypeScript ecosystem is still one of the biggest ecosystem in the development space. And having a language that could look similar to that means that we could attract a lot of people from that ecosystem. And not just attracting, it makes it easy for any of you listening right now to get access to start building immediately with your experience and just learning a couple of other syntax and you should be good to go because of the familiarity between this language and TypeScript programming language. So now, how do you use Compact, to build smart contracts? What are some of the things that you need? What components do you need to get started? How does it even look like building smart contracts with Compact programming language? So to keep things very simple, Compact is a very strongly, statically typed language bounded within a smart contract knowledge, and is designed to be used in combination with TypeScript for writing smart contracts, and also for the three-part structure of Midnight, which I'm also going to talk about in the next slide. So that's exactly what Compact does for you, and how it's also been designed to help you combine your existing knowledge I mentioned with JavaScript or TypeScript when you want to write smart contracts today. So what are some of the fundamentals here, which is the key structure of Midnight that I mentioned? The first one here is when writing compact smart contracts, right? Or when writing a smart contract using Compact, you have a couple of things to look at. So first one here, which is the primitive here, is the ledger, and it is used to define an on-chain program. I'm going to show you what that means during this demo session. You see a sample contract and see where ledger is being utilized. And then we also have another function here, which is the witness. And this is a foreign function interface to TypeScript used to define an off-chain programs. And where witness is important here is an off-chain computation that is happening during the process of you generating proof. We can inject that into our contract with this particular function called the witness primitive, right? And that makes it easier for us to have an interface that can to have something that can interface with an off-chain program. Right. Now, we also have circuits. Circuit is also another one used in contracts that helps you define the ZK circuit, linking the two above. The two here is is what I mentioned earlier on as regard the ledger and witness. And then final part of it, which is like an extension that I really wanted to add to let everyone know about, is there's also something called disclose that is most common when you are building a privacy smart contract with Compact. And that disclose helps you to have if you have a fact about a local data that you want to make public, because when you're writing contracts with Compact, the default is private, right? But if you have information that you want maybe your front end to read, or you want to disclose to the public and make sure that they can read this information, then you need to use this disclose keyword, and that will allow you to reveal some data to the public. So before I proceed to all of the primitive type that we have, I want to pause a bit to see if we have any question in between. If not,
Yes,
then go ahead.
yes, we do. Yes, we do, Idris.
Okay.
Yes. I had a question: is opaque string type is visible as a string when querying public state of the compact contract? This question further moves to, can, let's say, I have a voting contract with a map of opaque string and unit.
Sorry, I'm trying to understand the question. Yeah, the first one is visible as a string. Yes. When querying public state of data. Yes, that's correct. So in the example, we have an example on our documentation today, an hello world example, and then we defined a variable with this string type called the message, and then you can save any data inside that the variable itself, and that is a public string data available. But then that's not the end of it. Like I mentioned, it is private by default. If you then want to disclose whatever information that is needed, then you need to call one of the key um, fundamentals, part of the fundamentals that I mentioned with Midnight earlier on, which is the disclose keyword, to make that particular data in that string visible. So by default, it is not visible, but you can make it visible. Don't worry, when I get to the demo side, I'm going to like show the exact example of this particular use case, and you see how it is being utilized on chain. And then
Okay,
to the other one, yeah. So to the next one, you said you are working on a voting contract.
it's this. Can let's say I have a voting contract with a map of opaque string and unit.
Okay. I think that's, can you move on to the next one? It seems that's a is an incomplete statement. Okay, yeah. So it says, let's say I'm making a voting contract with a export ledger map with opaque string and a unit to display them on chain and get tally function. Will it give back the format string? I don't quite get your question. But if I'm going to translate what you mean, I'm guessing you mean when you export a map, a ledger map with an opaque string and a unit 32, if you want to display them on chain, is it going to give you the same format? I would like to confirm is that what you are mentioning. But then it's important to know that if you set any primitive type, irrespective of what it is, as it is on my screen right now, you can see we have a couple of them. We have Boolean, we have uint, we have field. It won't change for any reason, right? Irrespective of how it is being utilized. Because once you set the type, that type remains for that particular variable that you set it to. So I hope that answers your question, if that's exactly what you're trying to confirm.
Okay, we have another one is also the midnight node RPC was facing some issues yesterday full day. I
Oh,
had to on the standalone version. Will it be resolved soon, or can I, for the hackathon, work on the standalone version?
yeah, we are actively working on it. See, so that happened yesterday. I think you should give it a try again today. It should be good to go, unless there's something. There were, I think we publicized a particular info on our Discord to announce this, so it's a known issue that we are aware of, and we really appreciate everyone's patience and apologize for any inconveniences caused.
That's it for now, Idris. We can move forward.
Yes, all right. Thank you so much. So now it's just right in time. I asked that question and somebody was already asking about something related to primitive type. By the way, these are the primitive type that we have. Don't mix it up with what I mentioned earlier on around the key components of compact contracts. We have the ledger, we have witness, we have circuit, right? Primarily, I added this close here because it's also a very important thing. We've seen question in the past relating to what happens by default on chain. Is my data public, or how is Midnight handling data by default? Which means on chain today, all your data or your implementation is private. If you need to make any of those data public and readable somewhere, then you need to call this disclose method and then wrap it around the data that you want to make visible to make that particular data available for anyone to see. So now we started talking about the primitive types when the question came in, which is like right in time on what you can do with primitive types. We have a couple of them. We have Boolean, we have uint, we have field, which is an element of scalar field, and it is used for proving system. We also have tuple, just like the way you see with any other programming language. In this case, we also have vector. We have byte. If you are already familiar with writing smart contracts, this should be pretty easy for you to grasp. We also have the opaque, which is the primitive type for So string value, if you want to like create a value on chain, this is it, and it's a string. This is the primitive type you would use. So I also wanted to quickly touch on, I mentioned circuits like a couple of times. As you can see here, we have this circuit for full, and then it takes in a uint here and 16, and also return uint 16, right? We have a couple of things to note here: assertion and constant. We have like const, you can have the constant variable, you can have assertion, like assertion, if you are familiar with like any other maybe Solidity programming language, is what they have as a required element here that kind of verifies something before an action is being carried out. So in this example, you can see we have circuits, which is one of the core components I mentioned, and we also have this keyword export that makes this particular function visible or available for anybody to query. And then you have this very simple example, which is really looking like, if you look at it very well, if you're already familiar with TypeScript, it's kind of the same, except a couple of things here that is different. And then just like every other programming language, you have like conditionals. Also, when writing Compass smart contracts, you have an if statement, a return statement, depending on the type, the primitive type you want to accept or return. It just works the same way like you would do with TypeScript today. But now there are a lot of things there. I do not want to like go to every detail because at the end of the day, you need to find a way to get started on your own, and then making it easy for you to understand what's under the hood and then how compact programming language works. Right. So I'm going to, in this demo, you can scan this QR code. It takes you to the example that we're going to go through together during this demo. So let me kind of switch my screen a bit. Give me 1 second. Okay, so I'm going to share my entire window now so you all can see my screen. Yeah, can you bring back up my screen, sorry? Okay, thank you. Okay, so now if you scan this QR code, let me make this bigger. Yeah, so if you scan this QR code, this is where it's going to take you to a repo called the B-board. So it is going to redirect you here, right? And this example, it's a very good example because you can have, it's a B-board example utilizing the compact contract itself and a CLI environment, and also a UI that is built with like React. The interesting part is if you go through this particular template, you get to see individual component of how the compact is written, and then what are some of the implementation there, how ZK proof is being implemented and generated, and then you also have a UI that you can use to interact with this contract directly on the fly. So, and of course, it's also on our docs. You can access it directly after this presentation. So it's a very simple one. And then what I'm just going to do is I'm going to follow the step by step, just like we have on the docs, and which is typically the way you would, run it by yourself. So I'm going to head over to my terminal. So to get started, we have, okay, can you see my terminal? No. Okay, I would like to show my terminal. I don't know. I think I have to share the entire window. Okay, the entire screen. Yeah, perfect. Yeah, you should be able to see my terminal right now. All right, perfect. Thank you so much. So now, For you to run this example, there are a couple of things you need to know, but let's go through the docs and see what is available. So the project structure looks like, we have the contract folder, we have the source folder inside the contract folder that contains contract source and other utilities. We have the API folder that contains method, classes, and every other thing, every other like thing around types for CLI and UI. Then we have the Bboard CLI folder. We have the Bboard UI folder. Don't worry, this is something you can run on your own. But prerequisite here is that we need to check to make sure that we have what is required. In this case, the prerequisite here is that you need to check your Node.js version, and I'm just going to quickly do that. To do that, you can just run Node.d to check and make sure you have version you are using is 22 or above. Anything that's the expectation. Like you see now, I've checked mine and mine is good. You also need to have Docker install. So if you have Docker install, you can just run it directly if you're on Mac. If you're on Mac, you can, once you just open your Docker app, the daemon starts running and you are good to go. And then the next thing is, if you don't have it installed, of course, you can install it here. Another thing we want to do is you need to have your Lazy wallet, interface for UI implementation. So you can so the way this project works is that you have the CLI where you can just interact with CLI. But if you're utilizing the UI, then it means that you need to connect your wallet and do all of those things, right? So what we're going to do next is we're going to clone this project and then follow the command here to do all of the installation. We compile it, and then after compilation, we try to run the CLI just for this demo. You can choose on your own to run the UI interface instead if you want to. So what I'm going to do now is head over to my terminal. I think I have this. I can So I don't know if I need to zoom in. Let me zoom in a bit so that you can see my terminal. Yeah. Okay, I think this should be okay. So now I'm going to head over to this. And then I will just open it in my IDE. Yeah, so okay. So now let me zoom in so you can see my screen clearly. So now you can see the project structure. And then on this project, we have the Bboard CLI folder, we have the Bboard UI, and then we have the contract folder. Before we start anything, I want to quickly, let's just complete the installation and then I'll run through the example just to show you what I was trying to explain during the presentation on some of the contracts you can run and then how you can, how it is being implemented on chain. So if we take a look at our example, step by step on the repo, it says after cloning, then we can come here and run npm install, cd into the API, and then run npm install again. So there are ways you can do it. You can copy this directly here and just run npm install generally. While this is installing, you can also look at the next one, and the next one is to install the API dependency. And to do that, we need to change directory into the API folder and run npm install, and then go back to the root folder, right? And when we go back to the root folder, we'll do the same thing for the contract folder because they're already packages that are pre-built for you and already configured. All you just need to do is to run the npm install command, and then that install all of the dependencies required. So you can see this is now installed. So the next thing you want to do is clear this terminal. You want to do, like I mentioned earlier on, is to install cd into the API level and then install the package. So you can just copy the directory and then that happens immediately. Then the next thing we want to do is to see the contract and run npm install there also. So with that should complete all of our installation according to the readme here, right, that we have. So yes, we have this done. So installation complete successfully. Now we can go back. So before I start the command for running, compiling the contract and all of that, I would like you to see, or we look at the contracts together and see what it looks like. I'm trying to zoom in a bit so you can see my screen clearly. All right, so now we have, if you look at the folder directory, remember during our installation, we navigated into the API folder and then run npm install. And then we also then navigate into the contract folder and run npm install. So the contract folder is where you find like the actual contract itself. When you click on source, you can also see there's a test folder. But now for this demo, we just focus on the bboard contract. So yeah, this is what the contract looks like. And it's quite simple and straightforward. If you're already familiar with writing contracts, like most smart contracts starts with defining the compiler version for that particular smart contract. In this case, we are 16 to between 16 and 18, right? And then the next thing you see here is that we import the compact standard library. This is where you have all of the methods that you can utilize already available for you in this application. So importing this library makes those functions available for you to utilize within your contract. And then the first thing that happens here is that we have the states. So this billboard thing is, for every billboard, there's usually a particular information that is being displayed. And the state here defines is either the billboard already has a data that is currently being displayed or it is vacant. So it can either be vacant or occupied. So what we are trying to do is we want to capture both states or like both scenarios. That is why we have the enum state here, and one with vacant key and then the other one with occupied. Now, after defining the enum, that's not all. We want this to be a state that is saved on the ledger itself. So we define using the ledger keyword that I mentioned during the presentation and create a variable using the enum state, right? So now this state itself would have two pre-configured states that's in using this enum, which can either be vacant or occupied. And then the next thing we want to do is message. So the question somebody asked earlier on about the string itself, you can see we are defining this as a string. Here we define it as maybe, a string here. And what this means is that this variable can take in a string. And then we also define another one called sequence, which we are using the counter primitive here for sequence. Like as we create a value on chain, we can keep track of what that value is, or like we can do an incremental state for that particular action whenever we do. So we can just utilize sequence itself and then call the increment function on that sequence data, on the sequence variable itself. And then finally, we have the owner, which is to identify who owns that particular data that is currently being displayed on the billboard. So that defines all of the variable that we need for this contract. Then you can see here we have constructor, and what this simply does is the first we want to set a predefined state for our state variable. In this case, by default, we want, once this contract is triggered or initialized, we want the first state of the state variable itself should be vacant. That is why we are setting it as vacant first. And then we also want to make sure that the message variable is empty, which means that it is empty by default. And then finally, we want to start the sequence from 1 and make sure like it starts from 1, right? So by default, we're starting from 1. So we are always sure that the counter will start from 1 and the first message will be saved as 1. Now, the next thing I want to like talk about here is witness, and I'm going to spend a bit of time here because it's very important to know that witness play a major role in how privacy is achieved within a smart contract. Because if you are building your smart contract, how do you then identify which data needs to go on chain, which data needs to be off chain? What do you need to run this data in a way that users can safely connect their implementation, and users can safely connect to the application, and then user can also be sure that they are not sending any other info except what is required as a proof to submit in that contract. So how do we assess the private state? So if you think about it, how do you retrieve a key from a user in a way that it is private? So we need, we defined a circuit here already, but then how do the function called local secret key itself, as I highlighted here, cannot be another circuit because the value returned by the circuit are publicly verifiable, and then the value returned by this function should never appear on the ledger, which is why this keyword witness is very important, because we don't want the user's local secret key to appear on the ledger. So this kind of function is called a witness, and witness function provides the API to the private state of the contract as maintained by individual dApp that use the contract itself. So the contract does not describe the definition of the witness. It merely just declares like the witness's existence, and the dApp must implement it. So that is why you have the witness keyword here, and that is why this exists here in the first place. Right. It's important to know what this does, and I also believe that you can experiment on your own to see what is happening under the hood. So moving on, we have a circuit function called post. Of course, if we want to update or create a new message and post it on the billboard, we need something that can allow us to post that message, and that is why we have this function here, this circuit here that allow us to post a message. But a couple of things we want to check before you can post the message. We want to make sure that the state is vacant. Of course, we want to make sure that the billboard do not have information at the time that you want to post your new data. That's number one. And then the next thing we are doing here is that we also want to make sure that we can assign the owner, which is who is currently interacting here, because we can use that by connecting to the local secret key here. And what that gives us access is to using this disclosed keyword is to know who the owner is in this case. Who is that person trying to post that message at the time of calling this function call, which is the post function. And then next thing we want to do is to assign the string, the new message that is currently being posted to the message variable. And then finally, we want to update the state to occupy. Remember, we checked the state here that it is vacant. But now, after specifying the owner and then saving the new message to the message variable, it means that we can safely update the state to occupied, because now there is a function that currently exists. So that's for the post method. What other things do we need? We need the takedown method itself. So the takedown method here is quite simple, right? And what it does is, as the name implies, like take down a post, because now we have the post already live on the billboard. and then we want to, on the bulletin board, I'm saying billboard, but yeah, it is like, you can take that, it's like the bulletin board itself. We want to show one thing happening, right? And then the first thing we want to check is this occupied? Because we are attempting to take down the post. We want to be sure it's already occupied. So if it's not occupied, then it means that it is vacant, and then the check can pass. Then the next thing we want to check is to confirm the owner who posted that particular message. Is it the same person that is trying to take it down? If you notice, there's a public key here, which is another function that is being utilized to have a persistent hash, combining your local secret key. So utilizing your local secret key, you can leverage that. So let me give you paint a scenario here, or to explain further. To return the value of witnesses, which are presumed to be a private data because it's a local secret key, right? The compact compiler tracks them through a program that prevents them from, leaking by being reviewed in the public ledger state. So specifically, it means that in the post circuit here, the result of the local secret key is presumed to be private because the value is passed to the public key here, which is the other function that we specify. The value is passed to the public key, and then the result of the public key is also presumed to be private, or at least based on a private data, so that the compiler would signal an error if it were to written into a public ledger state. In this case, however, we have like the hash of the owner and then the owner's identity that combine with the sequence counter, which is what you can see in this function here. And that also ensures that it will not leak the owner identity at any point. And then wrapping the public key into a disclose tells the compiler that the disclosure is intended. So which is what is happening here. And you can also see the same without the disclose function, you can see the same implementation happening here. So what we are just trying to do here is to make sure that we do not leak any information, because presumably it's private by default, and during the process of trying to access, we don't get to leak any of this information. But this assertion implies that we are first checking if the person that wants to take down this post was the person that initially sent this post earlier on. That's what this assertion is doing. And then from that, if all the check pass, we want to then get the value of the current message, which is now the former message, because the message is about we want to take down the message. And then we update the state variable to vacant, right? To remove, just to update the state that now it's no longer occupied, it is empty. And then finally, we want to increment, the sequence. And then we can now safely set the message variable, the message content to none, and make it empty, and then return the former message, right? So yeah, we are setting the message here to none because we are not updating the message. We are only just taking down, the post itself. So now we have, that is what is happening here in the takedown method, using it with the public key. So I'm going to pause again a bit to see if there's any question. So I think we are good. If there are no questions, then I can proceed. But the interesting part is that you can play around with these things yourself, to see how they work, practically experiment them on your own. And then let me go back to the guide, where we can now run the compact contract and also build the contract. So you can notice we have the contract and we've already cd into the contract folder. So we can now run npm run compact and then build the contract itself. So this is going to compile the contract itself, and now it's verifying once that. So you can see it indicates what are some of the things that we have, the two key circuits that we have on the contract itself, and this has been compiled successfully. The next thing we want to do is to run build, and then this already build the contract itself. So you can see we have this, and now we have a new folder called dist, where inside the dist we can see like the compiler information that gets generated, the contract itself, like the JSON file available to us. We have the keys, which shows like the post itself, the post verifier. For post we have the prover. For post we also have the verifier data, and then we have takedown. We have takedown the prover, and also takedown for the keys for the verifier, and then we have the ZK directly for both post and also the takedown method. So now we successfully compact and run our contract. The next thing you want to do is you can CD back to the root folder. So if you compact your contract, which is similar to what we just had, you can see an example of what we did here. So now what we want to do is to be able to test this application and see if it is running. And of course, you can do this on your own. I'm just quickly showing you what could be done. So now we're going to CD into the bbot CLI and then run npm install and npm run build. So to do that, you need to change directly back to the root folder first, and then clear. And then we can now cd into the bbot CLI, run npm install, I believe. Yeah. And then after npm is installed, then we can run build. I'm just basically following like the instruction, which is the same way you would do on your own internally. So now we are only focusing on building the interface, and which is what we just did. Now the next thing we want to do is for us to run this, we need to make sure we have our Docker file running, because the proof server must be running before using this, because I already have my Docker up and running. And initially, part of the installation is to have Docker installed and also set up. So since we already done that, the next thing we want to do is to cd into the bbot folder, the bbot CLI rather, and then run this command line for us to start our Docker and make it up and running. So what I'm going to do next is trying to see, let me see if I can. I want to, let me quickly cd into that directory so that we can have different terminal. Yeah, so I can run the command on this terminal, and this should start, the proof server. As you can see, we have, the proof server started, right? Now, our proof server is running. The next thing we want to do is to run the command to start the CLI itself, which is what npm run testnet remote, and we should see a couple of details on our terminal. Then I can do that by just running the command, and then you can see we have the CLI running already, and it asks us a couple of things. If we want to build a fresh wallet, or we want to build a wallet from seed, what are some of the options available to us? So you can choose either of the two by building a wallet fresh from seed, or if you already have if you already have a wallet, right? But if you don't have a wallet, you can choose to build a fresh wallet, and that should help you in this. So if you select, for example, what I'm going to do here, I'm trying to look for an example that I can use here out of the box. Yeah, 1 second. Yes, so if you select So what I'm going to do for because of this demo purpose is I'm going to build from a particular seed, right? And from that seed, I can just tell that I want to build from the seed, and then I can enter my seed wallet. And now you can see it says your wallet seed is this, and then the address, the balance. It's saying it's waiting to receive token, right? I already have token, so you can see it gets updated automatically and displayed my balance here. And now the next thing is, do I want to deploy a new bulletin board contract or join an existing board? I can choose to redeploy my contract or join an existing board. So let me review the contract. And what this is going to do is to deploy our contract that we've already compiled here. The same contract here is going to deploy this contract for us. And after deploying the contract, then we can now interact with the contract by creating a post or taking the post down, which this CLI would also like prompt you to do all of those things out of the box, right? It could take a few minutes, or we could also try, joining an existing bulletin board contract that is already deployed that we can just, interact with, right? So this is an example, a very critical example for anybody trying to learn how to write or build on Midnight for the first time, or you already have some experience building on Midnight and you need an example that uses both, witnesses, that's your private state generating ZK proofs, and also an interaction on chain. How can you have both implementation on chain? How can you work with them together? So because of time, I don't want to delay, but this is how it looks like in a simple step. And as you can see, it's a CLI that it's up and running. Once you move from one action to the other, you'll be prompted on what to do next, and you don't have to worry. Just follow the guide, and you'll be good to go. So now I want to go back to my presentation and then try to wrap this up. So we are currently here in case you don't have this. So this is the demo. You can scan this QR code, it takes you directly to the GitHub repository, and you can follow the instruction there. Now, the final part of it is resources. Resources plays a major role when you're trying to build as a developer. You also want to see what people are building in the industry. What are some of the things you can learn during this process? So we have the developer hub here, which is our one-stop shop for the updates that we have on Midnight, or just anything happening within Midnight. You could check here. And then we also have the getting started guide, which is on our docs. So what I just did is a bulletin DApp, which you can find here under build, under tutorial. If you click on from scratch, you see a even more detailed explanation on what is about to be done, the contract itself, the DApp itself, the environment, and the DApp updatability, right? And these are all of the things you can follow. This is what we just followed within the demo session. But if you check the getting started, if it's your first time, don't worry, you can get started here, follow through the installation on what you need to install, the environment you need to configure, and then follow this step-by-step guide on how everything is done. Wanted to call out here, if you want to have a quick start to just get started quickly, you can also run this npm package here. Once you run this npm package, it bundles everything that you see in create, deploy, and interact for you, and then help you get started quickly. But if you want to do it one after the other, then you can just follow every other steps that you have available in this documentation. It's quite very easy for you to get started immediately. And then we also have the Awesome DApp repo. Awesome DApp repo contains some dApps that builders are already building, and a very good examples that you can take a look at and see how things are being implemented. Even examples from OpenZeppelin to build the token contract, fungible, non-fungible, or 1155 tokens. You can see developer tooling, some of the toolings that are available to you that you can utilize out of the box. And then finally, our YouTube channel is also where you could find a lot of. So we had live sessions. We recently had the Midnight Summit, but we have individual fireside dev hangouts that happens every week. If you take a look at some of them, most of them are like implementation that you can follow through out of the box. I would encourage everyone to check it out, and also videos if you want to zoom out and learn non-technical implementation, how it is being done. You should check out the Midnight YouTube. And then yeah, that brings me to the end of this presentation. Thank you so much. I have this QR code. Please scan it and give me a feedback. Tell me what you think about this presentation. It takes less than 1 minute to fill in. Let me know what you think about this presentation. Let me know what is missing that you think could have been touched on. And let me also know if you find it helpful for you to get started, because we have another session that is pretty much advanced than this, that you would learn more. But this should serve as a foundation for you to get started so as to understand the next session for Midnight even better. So thank you so much. You can find me on all social at all and stuff, and I'll be happy to answer your questions.
Thank you, Idris. So we do have a question. Is so the deploy will not work. It
Oh, okay. Yeah. So mine worked. I don't know. Can you see my screen? Okay, yeah. Oh, yes. This is a known issue. I remember clearly. If you have tried it earlier on and didn't work, we had a testnet rundown that happened that's currently being looked into, and that is why it won't work. So it works out of the box, but yeah, that's why that won't work. So once you find all of the information on the Discord, just take a look at Discord. We've shared update earlier on the progress we've made so far. Take a look at the Discord and they will update you as things go. Someone
got
said I
it.
should send the PDF file. Yes, I will send a link to the presentation. Maybe I can drop it now.
You can drop it in the private chat. I will post it.
All right, thank you. So yeah, so you can have the presentation I'm going to share with you. Take a look at the presentation. Let me know what you think. I'll be happy to answer all your questions.
Thank you. We do have some pre-recorded questions with us as well, Idris, that we would like you to answer.
Okay.
In Compact, what is the simplest way to define private versus public state inside a contract?
Sorry, can you repeat that again?
Yes. In Compact, what is the simplest way to define private versus public state inside a contract?
Yeah, so inside a contract by default, like I mentioned during the presentation, is by default the state of a particular variable on a contract is private by default. So if you want to make it public or make it accessible, then you should use the disclose keyword to make that particular variable accessible to anybody.
Great. We have another live question with us. How to integrate Lace Wallet and Hydra
Right.
L2 in Midnight Network?
For now, I don't have a direct answer to that. But the goal for Midnight going forward is interoperability is part of it. We would be extending to other ecosystems. That's the design. This is just me telling you from the design perspective, but we are not there yet. And I want to assume, because you mentioned Hydra L2, so the assumption here is that since we are going to extend to other blockchains, L1s and L2, it will be easier for us to connect with any other ecosystem. Yeah, that's part of the design, it's part of the plan, but not available directly today.
Got it. Another pre-recorded question is when executing a private transaction, what information stays hidden and what still ends up visible on chain?
Yeah, so when executing a transaction, a quick rundown would be if a user wants is interacting with a dApp and needs to send in an information on the dApp. So what is happening is that there's a proof that gets generated on the user machine that does not get, like, user data do not get uploaded to the network. What gets uploaded to the network is the proof that is generated from that user data, and that gets bundled alongside the transaction and gets sent to the network. So only a proof is sent from the user data, which means that it keeps the user data on the user local machine and that remains there forever. Only a proof gets sent to the network. So that's how you differentiate. Um, if you understand that concept of interaction, where proof is being generated and only a proof is being submitted, um, that would help you to understand what exactly is going on chain, because only proof verification happens on chain, not the actual user computation on chain like you would see from any other blockchain out there. I
Okay.
hope that answers your question.
Yeah. What tools or commands should beginners focus on first for testing compact contracts locally?
Yeah, just I shared the link earlier on, but I'm going to share it again. The best way to get started to deploy something without any complexity is our docs, and that is the getting started guide that we have on the docs. See, if you go through these docs, it's going to take you from zero to hero, like I like to call it, right? Because the hello world example there, it's a very simple example, and then the guide entirely shows you how to write the contract, that example, how to deploy the example, sorry, how to compile the example, then deploy the example, and then interact with the example. So it shows you step by step.
Got it. Got it. Another one we have is, what are the easiest real world use cases to build with Compact for someone just starting? Voting, small DeFi flows, messaging.
Yeah, there are a lot of use case, to be honest, but if you want a basic application, maybe a voting contract, so which is similar to the billboard contract that we have or that we showcased during the demo. So, for example, the billboard contract shows like you posting a message on a bulletin board, right? Meanwhile, if it's for a voting contract, building a contract that can allow people to vote for something, and then they vote without disclosing who they voted for, but generating proof for that particular vote. That's a very basic example. But during my presentation, I touched on different verticals of like what you can do today with Midnight, and it cut across both gaming ecosystem, identity solution, healthcare system, and even DeFi, financial ecosystem. So those are like the categories that you could build applications for today. Just think about all of the applications that you can build on, public blockchains today that do not support privacy. Those applications could also be replicated in the privacy world easily.
Got it. Got it. So another one we got was, if something goes wrong during a private transaction, what debugging steps actually work given the data is hidden?
If something goes wrong, sorry, could you repeat that?
Yes, please. Yes, I will. If something goes wrong during a private transaction, what debugging steps actually work given the data is hidden?
Oh, yes. So that's a very good question, because if you look at it very well, since the data is hidden, the assumption is that everything is hidden from the world. But let me point something out, that privacy is not secrecy. Like, you are not trying to hide. What you are just doing is computing things, and then taking things offline instead of putting it publicly out there. So what that means is that today we have, if you follow our installation guide and everything, we have a very simple debugging tool. By the way, the compact language itself returns appropriate error for you if you're trying to debug. In case you're trying to compile your contract and it's not working, you get to see like the error returned, and from there you can debug. That's one way. Another way also is by writing tests. During the test implementation, also you could also get, you could debug. But to point out, because it is private does not mean you cannot debug it, because the difference here is that every action require maybe not every action, maybe like depending on the action or the contract you're interacting with, those some of these action have like requires proof to be submitted for something. And that case, what you are dealing with is not the actual user data. What you are dealing with is the user proof that is being used to submit something and how that gets verified. So it's not like you are hiding. Since it's a mathematical computation on the proof side, the proof is available and visible, but then it just needs to get verified on chain. So you are not basically hiding anything during this process. Like technically hiding, but what you are doing is being able to like generate something that is verifiable to any other person.
Got it. Got it. Another one we have is, how does deploying to the midnight test net differ from deploying a contract on a typical non-private chain?
No, I think it's the same flow. We have RPC also that you could deploy your contract on. It's typically the same flow because you need to access this environment remotely from wherever you are, just like any other blockchain. So once you get access to the testnet RPC, you can deploy on the testnet. And when the main net is live, you can also do the same thing.
Got it, got it, got it. That's it from my end as well for today, Idris. Um, thank you everyone for joining Workshop 5. Special thanks to Idris for the expert guidance that he has shared today. We look forward to seeing the innovative privacy first dApps you built as a part of Cardano Hackathon Asia IBW Edition 2025. Thank you, everyone.
Thank you so much, guys.